Salam all. So we are going to continue with the lecture. For this second round is talking about the stack. Okay. So what is stack? The definition of stack is actually is an area in memory RAM. Okay, remember that you have the RAM. So there will be a stack, will be an area inside the RAM reserved for reading and writing special or temporary data such as return addresses and registers values. So previously I did taught you guys about the return addresses in the program control. So other than return addresses, the data such as from the registers can be stored over here. Okay, so for example, that from the data register you can send to the stack to be reserved as temporary. Okay, for maybe for swapping values, you just want to put something over there and then you can call it back. Okay, so there are two operations for the stack. So before that, before I proceed, where is the stack? The stack is at your memory. So if you go to the memory locations, so you can just write anything over here first before you execute it. Move.long $ hash $ AA to D0. So you just run this one and then you just execute and go to the memory. So this is your memory. So by normally your program will start at 1000. So this is your first memory location over here at 1000, but the stack is not over here. The stack is at the end of the memory locations, normally pointing over there, which is pointed by A7. This one we call it A7, also known as a stack pointer, the pointer. Okay, a stack is a stack, a place for you to save something. Stack pointer means it's pointing to the location of your stack. For this example, this is your stack location. So if you double click this one, you directly go to this location at 1,000,1000,1000. So that is the locations of your stack that is pointing by the stack pointer. But the thing is, it is not at the X version over here, because the X-axis, there's nothing over there. The RAM is not we don't have any RAM over there, but it will start from the 1 million over there, and it will start from here and going upwards. Normally when you play with the memory, you're going to put the data from the left to right, but for the case of stack, you are going to save the value from right to left and going down. If you save a value from to the memory, it will going from the small values and then it will increase to the higher level of the memory locations. Whereas for the stack, you are going to save and the memory is going to be decreased, going down. Okay, what else? The stack has two basic operations. One they call it push, and another one they call it pop. Very easy. Push means you are pushing a data to a stack. Pop means you are going to take out the data again from the stack. Quite simple. And then the syntax is going to be like move also. Move the size from what to the stack pointer. This is calling from the stack pointer, go to anywhere that you want. Okay, this picture, remember that this one is about A7. Remember that A7 is your stack pointer. In bahasa, in bahasa it call it penunjuk tindakan. Okay, this is a stack pointer. Okay, that's why they call it pointer. Stack is a stack, pointer is pointing to the locations of the stack. And then we have the push and pop operation, where the push is to push a data to the stack, and the pop is to call back the data from the stack. Okay, let's move on. Remember that this is your memory map. So it has the word with, so you have this one $, maybe start from 000 again, right? The end will be, this is the one. This is 1 million. After that, the 1 million is over here. Okay, this is the end, right? This is 1 million over here, $, 1 million. After this one, okay. So the stack pointing to this location. Okay, so the address, okay. The address of the last data item placed into the stack is pointed to by the stack pointer. Okay, the address, this is the address, is pointing by the stack pointer. That it will be the last item. If you push anything, the stack pointer will point to the latest address. Okay, so address register A7 is used as main stack pointer in 68K. A7, so A1, A0 to A6 is normally used for address register. A7 is mainly used for the stack pointer. Okay, so when programming in assembly, we can use a stack pointer as an alias. So that's why in this program, you are going to use SP instead of A7. Doesn't matter, because that is the alias for that. You can use a stack pointer. So this one will be your stack pointer diagram. So the stack just now, I show you just now from the memory, it's the same thing. This is a kind of another version of how do you see a memory. This is your memory map like this. It starts from 1 million over here. This is going to be FFFFF. So once you are going to put here, then your stack pointer will be changed accordingly, decrease the number based on the size of the data that you push in or you pop out. Okay, so the characteristic of the stack is that the last item push is always the first item. So they call it last in first out structure. So whatever is just like a plate that you put something, a plate. Let's say you have a plate. For example, you have a plate. You stack the plate one by one, and then you cannot take this one out first because you have to take out this one first. The last one will go out first. Okay, the last one will go out first. That's why they call it last in first out structure. So you can see from here, the empty stack, when you push any data, for example, you push A data, then it will stack here for the first one, and then you are going to stack again another value for B. Then you can stack on top of A. Then if you want to call A, you have to remove B first. You have to take it out first, then you can read A. If you want to put C, then you can put C after you remove out this one. You can see that this is by stacking process. That's why they call it stack. You cannot take out anything at the bottom over here just simply like that, because the pointer does not going to do that one. It must follow the rules last in first out. Okay, so that is possibly on the data or any data that you want to put as a temporary reserve. And another important thing for the stack is this is related to the return address. So remember last time when I taught you guys about inside the program control, okay, the program control, in the new video I'm talking about the return addresses. Okay, the return address is about when you do a subroutine, okay, then the subroutine will give you an address for you to go and return after it jumps. Okay, so that is the case for the subroutine. So return address is the one also can be saved into the stack. I'm going to show you the example later. Okay, the stack grows upward towards the low address when items are pushed to the top of the stack. So what does it mean over here? Let's say, for example, this is your stack, right? This is your stack. This is your stack. When you put, this is the address $00000. So this is $FFFFF. So this is $1 million. When you put a value over here, then your pointer from 1 million will move to here. because this is already filled up by the information, so it will wait for another information from this address. So you can see that this address is a big number going to a smaller number. That's why in this statement it will say that the stack grows upward towards the low address. So you can see that it going upwards towards the lower address. Okay, lower address. When items are pushed to the top of the stack, when you're stacking up, then the address will be decreased. Okay, the stack pointer always point to the top item on the stack. That's why when you put anything, right, so the pointer will pointing to the latest one on top of the information. Okay, when an item is pushed, when you push an item, it will decrease. That's why the value here will be decreased. But how many? It based on the size. For example, the size of long, it will decrease by 4. Okay, this is for long by 4. This is 2 for words. So what happened for the byte size? For the byte size, it will follow this one. It will not take only one, it will take 2 directly, because it just to make it just for the case of for the next item to be pushed is words, so it's not going to be at the odd area. So this is going to be an even area. So words and bytes will have a decrease of 2, and for the long word it will decrease by 4. This is only to put into or push into the stack. When it is popped here, then this one will be reversed. Okay, the item on the top is copied to destination. So you want to pop to somewhere else. You want to put to D2 maybe. You are going to put over there. And the stack pointer is increased. So it's reversed based accordingly from the push over here. So it will reverse the value based again on this size. If you put byte or word, it will add the value by 2 plus 2. If you are going to pop the value by long word size, is going to increase by 4. Okay, so this is how it works. So let's try to look it on the EZ68K. So this is how it works. So when you push from the value over here, the address will be going to be decreased. So let's try to have an example from your EZ68K. Okay, now we are going to use the command here directly to push something to the stack pointer. But before that, I'm going to put something inside the D1. Okay, move.long $$ AA BBCCDD to D1. Then the next command is to push into the stack, which is this command, move.long $D1 to stack pointer. Okay, this command is going to save this value, which is from D1 to the stack pointer. So let's run this one. Okay, now look at your memory locations. I have not yet executed it. Okay, still empty over here. Now I'm going to move this value to D1. Move to D1 over here. This is correct. And then this command is to move.long D1 to the stack pointer. So I'm going to push this value to the stack pointer over here. Now you are going to look at this A7 also. Now the pointing is at A7, 1 million is pointing to this one. So from this value, you are going to decrease by 4 because this is long word. Let's run this one. Now you can see that the whole contents of D1 is saved at this location. This is the stack area pointing by A7. So the value right now, the pointer is now no more 1 million, is FFF, FFC. So how the numbers get like that, I'm going to show you in the calculator. So by long word size, the value will be minus by 4. So base 3, so hex number is 1 million minus 4. The value now is FFF, FFC. So from 1 million to this value, it is decreasing because the pointer is going up here. Right? It's considered that the value of the address is from the big address number to a smaller number. So that's why they call it decrease. Okay. So let's try bytes instead of byte over here. Let's run this one again. Alright. I'm going to run this one. Look at this one, A7. Now look at the contents of the stack. Just run this one and then run this one. You can see that DD is put at this location because of the byte. Okay, byte, you have to minus 2 and it is not going to be put at the odd location. It must be put at the even location. So this is even, right? Yeah, this is even. So right now you can see that the 1 million just now minus, that's how many? Minus 2. The result is FFF, FFE. So same goes to words. Let's try words. Okay. Run this one again. Look at this one and look at A7. So the value now at the stack is now CCDD and your A7 still also at FFF, FFE, means that it's minus by 2. Same goes like the byte example just now. Long word will decrease by 4. So you can put more and more, like for example that you can just put another value, right? Maybe for example, long word again to the stack, but remember that your stack pointer for the first one had been changed. So here, okay, let's run this one. The first one is going to be saved in word size, which is going to be CCDD. This is correct. Now the pointer is FFF, FFE. So now long word going to push again. This is a push, so you have to push, is going to save on the next one. Push, push. Remember that this is push. You have to stack one by one. So once I execute this one, you can see that the long word now is being saved at this location because this is safe. Push. Now this one is FFFFA. Just now is this one, right? The number, so you have to minus another 4. Answer results minus 4. The result now is FFFFA. Okay, you can push a lot of data, but you have to remember that every time you push a data, the stack pointer will be changed accordingly to the size. So what happened to the pop? What happened if you pop the value? So it doesn't matter. Now you want to pop the value here. Move dot long. Sorry, don't take long first. Just take W. Okay. SP plus, right? Is it SP plus to D2? I'm going to copy. I'm going to pop the value from the stack pointer in word size to D2. Is that a problem? There's no problem. So let's try to run this command. Okay, this one. Okay, This one go to the stack pointer, and then this is a change. This one, now this one FFFFFA. Once you put the SP plus is going to pop out the value. Pop is going to read the value and put it to where. Now the pointer is at this one, pointing to this one. So move.w, you're going to take AA and BB, save to D2. AA and BB save to D2. Now your value at A7 is FFF, FFC. So how it works? So you look again this one. Okay, now the value, the first one is this one is going to decrease, it's going to be minus, right? So 1 million minus this one W 2, and then minus 4, and then this one not minus, this is going to be add, because once you pop it will increase back the address, the pointer according to the size. This is going to be plus 2. So the answer is FFF, FFC. So let's run this one. So the result is FFF, FFC, and the contents is not going to be erased. If you put the value here, if you go back and copy to D2, the value here still remain. It is not going to it is not going to erase it. So it's up to whatever data that you have put, you just let it go like that. Okay, so that's the process of push and pop. So you have to remember that every time you push a data, the stack pointer will be pointing to a new locations. Accordingly, if you stack, it will decrease the value, and if you pop, it will increase the value of the pointer based on the size. Remember that W and byte are the same size, is minus or plus 2. For long word, it's going to be plus or minus 4. This is a push, this is a pop. Okay. So this is the command that we discussed just now. So you can see that this is the example of push and pop. The EasyCC8K have been shown how you want to do the push and pop to the stack area. Okay. So example number 3, register may be pushed onto the stack with move byte instruction. So this is the one that we showed you just now. So there's nothing new on here, as long as you understand how to do the command, right? So this is push and pop by byte size. So this is going to be showing you guys about the incremented by 2, even though it is used byte over here, we have discussed before. Means that it must be on the even position, even address. Okay. So since stack area is for read and write data, so that's the reason lah. That's the reason why. Therefore, it must be placed in RAM. So this is a place because you want to read and write. Okay. Normally in the RAM, you can do it the read and write when the operation is running. Okay, ROM you cannot do that because you need to have a special voltage. So you can basically you can design where you want to put your stack. From this example, right? This is actually how you want to design your stack area. This is, for example, for the stack. Like by default, you have the stack at the bottom of the RAM. So just make sure that you know where do you want to reserve your stack, so your program are not going to overflow to that particular locations. For example, that you have a lot of code programming, right, and up to the going to the stack area, then they call it overflow to the stack area. So this is another version of how to design, but that doesn't matter. It's up to you where do you want to put it. All right, as long as it is in the RAM. Okay. So this is an example on how to write a program to swap a data. So to swap the data means that you have to reserve you have to save the data first somewhere else, and then you can erase the value on the other side, so you can get back and put it back. So just a replacement. So the stack is used as a place for you to store a data. That's all. So you can try to have this command, right? use the stack pointer as a temporary storage. So this is value, and stack pointer, this is given by 10,000. So you have to code correctly. So you have to understand where is going to be saved, because this is a swapping data, right, between D0 and D2. So you're going to store first, and then later you can call it back to the location. All right. So for the stack is very important for the subroutine. So this had been discussed in the program control. So you have to open up the video, the new video for the program control, where I discuss a lot about the subroutine, because subroutine is a sequence of instructions that perform specific tasks. Because this is when you have your program go to the subroutine, it must know where it wants to go back. So that's why they call it return address. Once it's go out from the main loop for the main program, so it go to the subroutine, then it will need the return address. Alright. Then so it is written once and is stored in specific area of memory, short the task and program. So that is where you are going to save, the system will save the return address. Okay, whenever the main program wants to perform that task, the processor jumps to the address of the subroutine, execute the subroutine, and returns to the main program. Okay, the subroutines will change the normal flow of instructions into the processor. So you have to go back to the new video for the program control on the subroutine and the return address. Okay, go back and look at that one, because that one is very important too. And then this is about the subroutine. It's just something that you want to do a repeated task, something like that. All right. This is just a discipline when writes. When you do the jump to subroutine, JSR, you must have the RTS, return to subroutine. So jump to subroutine, branch to subroutine, you must have the return to subroutine. If you jump and branch BCC, this one you are not going to use RTS because it doesn't matter. But this one, you must know that it needs the return address and this command to go back to your program. So go back to the video for the program control, then you can get the answers on that. Alright. So this is the one that have been discussed in the program control. I think that's all for this one, for the stack. Okay, you can try to complete your assessment on that. Thank you very much.